On June 11, 2026, forecasters at the United States Climate Service made it official. A pattern in the Pacific Ocean called El Niño had formed, and it was expected to grow stronger through the winter. If you find these calm reports useful, you're welcome to subscribe, and then we will get straight into it. What makes this one worth a closer look is its likely size. The odds now favour one of the strongest El Niño events since modern records began in 1950. The last time the atmosphere lined up close to this, back in the 1870s, the same ocean pattern helped set off droughts across 3 continents, and the famines that followed are estimated to have killed more than 50 million people. That number is real, and it deserves to be understood in full because the weather by itself did not cause it. Over the next 2 hours, this report walks through what is happening in the Pacific right now, why it echoes that far older event, what turned drought into mass death the last time, and why the same pattern today does not have to end the same way. We will follow the ocean, the maps, and the history, one steady step at a time. The story starts with water that is warmer than it should be. Along the equator in the Pacific Ocean, a wide band of the surface has been running above its normal temperature for months. That warmth is the whole event in its earliest form, before it has a name in the news or a place on a map. A few weeks ago, the United States Climate Service looked at the readings and issued what it calls an El Niño advisory. The plain meaning of that phrase is not complicated. El Niño conditions are present in the Pacific, and they are expected to strengthen through the coming winter. An advisory is a statement of fact, not a warning bell. It comes from the agency that watches this stretch of ocean every single week. The reading they care about most comes from a patch of the Central Pacific that scientists have tracked for decades. When the surface there sits about 1 degree Fahrenheit above its long-term average for several months in a row, forecasters call it El Niño. When the warmth climbs higher than that, the name stays the same, but the reach of it grows. Right now, the warmth is not sitting still. It is building. In the eastern part of that tropical band, close to the coast of South America, the water is already running warmer than average by a few degrees Fahrenheit. That is a strong early reading for this time of year. It tells forecasters that heat has been pooling under the surface and is now rising into the open air, where the atmosphere can feel it and respond. The reason a warm strip of ocean matters so much is worth stating simply. The Pacific is the largest single feature on the face of the Earth. It holds an enormous amount of heat, and when that heat moves, the winds and the rain move with it. A change in the temperature of this one ocean can tilt the weather of continents that sit thousands of miles away. That is the quiet power behind the calm word advisory. Forecasters do not expect this to fade soon. Their models put the odds of El Niño lasting through the winter at better than 9 in 10. In the language of the agency, the pattern is present now, and it is likely to hold and deepen as the year turns. For the parts of the world that El Niño touches, the strongest effects usually arrive in the northern winter, months after the first warm signal appears in the water. So the picture at this early stage is steady and clear. A warm band has formed where a warm band brings consequences. The people who measure it have said so plainly and put their name to it. Nothing about that first statement asks anyone to panic. It asks us to pay attention and to understand what we're looking at. This report is going to do exactly that, without rush. The current event is the spine of the whole story, and we will follow it in order, from the first warm reading to the winter ahead. Along the way, we will look back at the one time in the modern record when this same ocean pattern reached its most extreme, because that older event is the reason the title of this report carries the weight it does. For now, hold on to the simplest version of the fact. The middle of the Pacific is warm, warmer than usual, and getting warmer. That is where every thread in this story begins. A patch of warm water is a small thing to look at on a map. What it can set in motion across the rest of the planet is not small at all. Before we can weigh what this particular event might mean, we need to understand the machine behind it. El Niño is not a storm or a front that arrives and passes. It is a shift in the balance between the ocean and the wind across an entire basin, a balance that most of the time we never have to think about. When that balance tips, the effects ripple outward in ways that are surprisingly predictable once you see how the parts fit together. So the next step is the mechanism itself. What is actually happening out there, in plain terms, when forecasters say El Niño has formed? It turns out to rest on something as ordinary as the wind that blows across the water and the direction it usually blows, and what happens on the rare occasions when it lets go. Start with the wind, because the wind is where this begins. Across the tropical Pacific, the everyday breeze near the surface blows from east to west. These are the trade winds, steady and reliable, and sailors have leaned on them for centuries. They push the warm surface water of the ocean along with them, piling it up on the western side of the Pacific, near Indonesia and Australia. Over years and years, this steady push builds a deep pool of warm water in the west and leaves the eastern side near South America cooler. That cooler eastern water is not empty of life, just the opposite. As the warm surface water gets shoved west, cold water rises up from the deep to replace it along the South American coast. That cold water carries nutrients, and the nutrients feed fish, and the fish feed one of the richest fishing grounds on Earth. This is the normal state of the Pacific, and it holds most of the time. El Niño is what happens when the trade winds weaken or stop. Sometimes they even reverse and blow the other way for a stretch. When that push from the east fades, the warm water that had been piled up in the west is free to slide back toward the east. It sloshes across the basin, spreading warmth over the central and eastern Pacific where cooler water usually sits. That slow eastward slide of warmth is the heart of El Niño. Once the warm water spreads east, it drags the weather along with it. Warm ocean makes the air above it rise. Rising air makes clouds and rain. Normally, the heaviest tropical thunderstorms sit over the warm western Pacific near Indonesia. During El Niño, that whole engine of rising air and heavy rain shifts eastward, out over the middle of the ocean, following the warm water into its new position. This is the single idea that explains almost everything El Niño does. When the rain factory moves, the places that used to get the rain go dry, and the places that used to be dry start getting the rain. A country that counts on a wet season can find that season thinner than usual, while a desert coast that rarely floods can find itself underwater. The rain did not vanish from the world. It moved, and the moving is what people feel. Think of the tropical Pacific as a shallow pan of water that someone has been tilting to one side for a long time. The warm water sits high on the western edge. El Niño is the moment the tilt eases and the water rushes back toward level, warmth spilling across the middle of the pan. That single image holds the whole mechanism, and you can carry it through the rest of this report. There is a companion to all this that shows up in the air pressure itself. When the ocean warms in the east, the pattern of high and low pressure across the Pacific swings too, in a rhythm scientists call the Southern Oscillation. The ocean part and the air part are so tightly linked that researchers treat them as one system with one long name. For our purposes, the short version is enough. Warm water in the east, weakened trade winds, and a rain belt that has slid out of its usual home. None of this is rare in the long view. The Pacific swings into El Niño every few years, then swings back the other way into its cool phase, then settles neutral for a while, over and over. Most of these swings are mild, and most of us never notice them by name. The system is always breathing in and out. What changes from one event to the next is how far the swing goes, and that is exactly the question that makes the current event worth watching. Because a small tilt of that pan gives a small, quiet El Niño that barely registers beyond the fishing boats off Peru. A large tilt gives something else. It gives an event strong enough to bend a winter across North America, to dry out harvests in southern Africa and Asia, and to push the average temperature of the whole planet up for a year. How forecasters tell a small one from a large one, well before it arrives, is the next piece of the story. For most of the past few years, the Pacific was doing the opposite of what it is doing now. It was locked in the cool phase, the one called La Niña, where the trade winds blow harder than usual and the eastern ocean runs colder than normal. That cool phase had held on stubbornly, stretching across more than one winter, which is itself a little unusual. To reach El Niño, the ocean first had to break out of that cold pattern, and forecasters were watching closely for the signs that it would. The first clear sign came from under the surface, where most people never think to look. The temperature of the ocean is not the same all the way down. Below the warm skin of the surface lies cooler water, and the boundary between them can rise and fall like a hidden tide. Months before El Niño showed itself on top, a huge slug of warmer water began building deep beneath the western Pacific, waiting. Forecasters could see it in the readings from a network of buoys anchored across the equator, buoys that measure temperature at many depths and send the numbers back by satellite. Then that buried warmth started to move. a slow, broad pulse of warm water began travelling eastward beneath the surface, from the western Pacific towards South America. Scientists call this kind of pulse a Kelvin wave, and it is one of the clearest early warnings of an El Niño on the way. The wave is not something you would ever see from a ship. It is a gentle rise in the warm layer, spread over thousands of miles, creeping east over weeks. When it reaches the far side and surfaces, it releases its heat into the water above, and the surface warms in turn. What set that wave in motion was a change in the wind. Every so often the steady trade winds break down in a particular spot and blow the wrong way for a while, from west to east. Forecasters call these westerly wind bursts. Each one gives the warm western water a little shove toward the east, and helps launch another pulse beneath the surface. This past year saw a run of these bursts, one after another, and together they did the work of tipping the pan. So the collapse of the old cool pattern and the birth of the new warm one happened together, in stages you could track as they went. The cold phase faded, the subsurface warmth built, the wind bursts pushed, the Kelvin wave carried the heat east, and finally the surface of the central and eastern Pacific warmed enough for long enough that forecasters could say the threshold had been crossed and El Niño was here. The reason any of this can be seen coming is a genuine achievement, and it is worth pausing on. 150 years ago, no one on Earth could have told you an El Niño was forming. They felt the results without ever knowing the cause. Today the ocean is watched by buoys, by satellites that read the height and temperature of the sea surface, and by computer models that take all those numbers and run the physics forward in time. That is why an advisory can arrive months before the strongest effects, rather than after. There is one stretch of the calendar when this forecasting gets harder, and the ocean happened to pass through it recently. In the spring, the signals from the Pacific tend to go quiet and muddled, and models struggle to see clearly through them. Forecasters call it the spring predictability barrier. Once the season turns and the barrier lifts, the picture usually sharpens fast. This year, when it lifted, the models did not disagree. They pointed, almost as one, toward a strengthening El Niño. That agreement matters. When a single model predicts something, you hold it lightly. When 24 different models, built by different teams in different countries, all point the same direction, the confidence is real. That is the situation forecasters found themselves in as the warm signal firmed up. The question was no longer whether an El Niño would come. It was how strong the one already forming was going to get, and on that question, the early answers were striking. Not every El Niño is worth a report like this one. Most are mild or moderate, and they pass with a nudge to the weather rather than a shove. What separates a quiet event from a serious one is a single measurement, and this year that measurement is running high, so it is worth being precise about what forecasters are actually seeing, and where the line sits between an ordinary event and a rare one. The key number is the temperature of that central Pacific patch, measured against its long-term average. A rise of about 1 degree Fahrenheit crosses the line into El Niño. A rise of roughly 3.5 degrees Fahrenheit above average puts the event into the top category, the one forecasters call very strong. That may not sound like a large gap in everyday terms. Across an ocean the size of the Pacific, sustained for months, it is an enormous amount of extra heat, and the difference in global effect between the two is large. As of now, the Climate Service puts the odds of reaching that very strong category by winter at close to 2 in 3. In plain terms, the most likely outcome on the table is one of the biggest El Niño events in the modern record. One respected European forecasting centre goes further still, projecting that the central Pacific could warm to more than 5 degrees Fahrenheit above average by December, with some of its scenarios running higher than that. Those are forecast figures, not measurements, and they carry the usual uncertainty of any outlook months ahead. But the direction they point is consistent. To understand how uncommon that is, it helps to know how short the reliable record really is. Careful global measurements of this kind reach back to about 1950, which gives us roughly 75 years of clean data. In all that time, only a handful of El Niño events, 5 of them, have reached the very strong level. They are rare enough that people who study the ocean can name them by their years the way you might name famous storms. The forecast now is that this event has a real chance of joining that short list. The build-up toward it has been quick, which is part of why it has drawn attention. Earlier in the year, the models gave a strong event only a modest chance. Within a couple of months, that chance climbed steeply, faster than it did in the run-up to some of the largest events on record. A rapid climb does not guarantee a record. It does tell forecasters that a lot of heat entered the system in a short time, and that the ocean is loading quickly rather than easing in. It is worth being honest about what these odds do and do not say. A 2 in 3 chance of a very strong event still leaves a real chance of something a step down from that. A strong but not record event. Forecasts this far ahead can shift as new readings come in, and a calm reading of them holds that possibility open. The point is not that the biggest outcome is certain. The point is that it is now the most likely single outcome, which for an event this consequential is reason enough to watch it with care. There is also a piece of context that sits underneath all of this. The whole planet is already warmer than it was a century ago by more than 2 degrees Fahrenheit on average, from the long build-up of heat-trapping gases in the air. An El Niño adds its own temporary warmth on top of that raised floor, so even a middling event today lands on a warmer world than the same event would have a few decades back, and a strong one can push global temperatures to new highs for a year or so before easing. All of that explains why forecasters are treating this event seriously rather than routinely. The measurement is high, the odds favour the top category, and the company it would keep is short and notable. But numbers on their own do not tell you what a very strong El Niño can mean for people. For that, we have to look at what happened the last time the ocean climbed near this extreme, in an age before anyone could see it coming. That is where this report turns next. The reliable instrument record only reaches back about 75 years, but the Pacific has been swinging into El Niño for far longer than we have been measuring it. Scientists can reach back past the instruments by reading other records that the climate left behind. Tree rings that grew thin in dry years, coral that locked the ocean's temperature into its skeleton as it grew, ship logs and harvest reports and diaries kept by people who never knew the word El Niño but wrote down the strange weather they lived through. Piece those together, and one event in the 1870s stands out above all the rest. The judgment of the researchers who have studied it is direct. The El Niño that peaked across 1877 and 1878 was very likely the strongest on record, stronger than anything measured in the modern era. There is real uncertainty in that ranking, because the further back you go, the fuzzier the evidence becomes, and honest scientists say so, but the weight of the reconstructions points the same way. In terms of raw size, that old event may still sit at the very top of the list. The fingerprints it left are the kind that are hard to mistake. Across the tropics, from India to the Pacific Islands, the reconstructed ocean temperatures show the classic warm signature, larger than usual. In North America, the winter of that stretch was so mild and strange that people at the time called it the year without a winter. Around the Indian Ocean, a second pattern that often works alongside El Niño was running strong at the same time, deepening the drought over southern Asia. Every thread of the modern picture appears in the old one, only pushed to a further extreme. This is the event the title of this report points to. When the atmosphere last arranged itself the way it is arranging itself now, with the Pacific loading toward its highest category, this is the era it echoes. And the reason that echo carries weight is not the size of the ocean anomaly for its own sake. It is what came after, on land, among people, in the years that followed the warm water. What came after was drought on a scale that is difficult to hold in the mind. The rain belt did not just shift by a little. Across a huge sweep of the world that depends on seasonal rains to grow its food, the rains failed and failed again, season after season. India, northern China and northeastern Brazil took the hardest of it, though the dryness reached into parts of Africa and Southeast Asia as well. 3 continents, linked by one ocean pattern, went dry at more or less the same time, and where the harvest failed, famine followed. The numbers that come down to us are estimates, reconstructed by demographers and historians from census gaps and records of the time, and they carry a margin of uncertainty. But even the careful, conservative versions are staggering. Taken together, the famines that followed this one El Niño are estimated to have killed more than 50 million people. Some historians, counting the linked droughts that came in the years around it, put the total higher still. By any of these counts, it stands among the deadliest disasters in all of human history. That is the promise inside the title, and it is a true one. The last time the atmosphere acted close to this, tens of millions of people did not survive what followed. It would be easy to state that number and let it sit there as a shock, and easy to let the shock do the work. This report is not going to do that. A number that large deserves to be understood, not just felt, because the understanding is where the real lesson lives. So over the next several chapters, we're going to walk into that history carefully, one region at a time, and look at what actually happened. We will start where the drought first took hold, in the fields of southern India, where the rains that farmers had counted on for generations simply did not come. Only by seeing how the disaster unfolded on the ground can we make sense of the most important fact about it, which is that the weather, terrible as it was, is not the whole reason so many people died. The drought reached India first, and it reached it through the monsoon. To understand the disaster there, you have to understand how much of the country rests on that one seasonal rain. For most of the year, much of India is dry. Then, in the summer, the winds turn and carry moisture in off the ocean, and the rain arrives in a great sweep that fills the rivers and soaks the fields and makes the whole year's farming possible. When the monsoon comes, the country eats. When it fails, everything that depends on it begins to fail with it. In the summer of 1876, over southern and central India, the monsoon did not come as it should have. The rains were thin where they should have been heavy, and in many places they barely fell at all. The hardest early blow landed on the high inland region called the Deccan Plateau, a broad stretch of farming country that fed millions. The crop that should have grown there withered in the field. What made it far worse was what happened next. The following season, the rains failed a second time. 2 failed harvests in a row left no reserve to fall back on. The scale of the dry zone is hard to picture, so hold on to one figure. At its worst, the drought and the hunger that came with it stretched across an area of more than 250,000 square miles and touched the lives of something like 58 million people. That is a region larger than many countries, gone dry at once, in a time before trucks or paved highways or any fast way to move food across the distance. The dryness was not a local misfortune, it was a subcontinental event. For a farming family, the failure of the rains followed a grim and simple order. First, the crop in the field is lost. Then the small store of grain from the last harvest runs down and is gone. Then, whatever can be sold is sold, the tools and the animals and the land itself, to buy food at prices that climb higher every week as grain grows scarce. When there is nothing left to sell, the family takes to the road, walking toward any place where food is rumoured to be, and it is on those roads that the dying began in earnest. The body does not fail all at once from hunger. It fails in stages, and the stages were recorded by observers at the time in language that is hard to read even now. People grew thin, then skeletal, then too weak to walk, and hunger rarely kills by itself. A starving body cannot fight off illness, and so disease moved through the weakened population, cholera and fever and dysentery, and carried off people whose bodies had no strength left to resist. Many of the deaths counted as famine deaths were, in the immediate sense, deaths from sickness that a fed and healthy person would have survived. The rains had failed before in India, across its long history, and the country had known hunger in earlier centuries. What was different this time was not only the size of the drought, but the world it fell upon. India in the 1870s was governed from far away, run as part of an empire, its economy reshaped to serve that empire's markets. The grain that a region grew was no longer simply the food that region would eat through a hard year. It had become a commodity, moved by rail and shipped by sea to wherever it would sell, according to rules made in distant offices. That distinction is going to matter enormously as this story goes on, and it is worth planting the seed of it here. A drought destroys crops. A drought does not, by itself, decide whether the food that still exists reaches the people who need it, or whether it is carried away instead. That decision is made by people, by the systems they build and the rules they follow. In 1876 and the years just after, the drought supplied the failure of the harvest. What turned that failure into mass death was, in large part, the answer to a human question about who got fed. We will come to that answer squarely, but first the human scale of what happened in India deserves to be seen on its own terms before we weigh the reasons behind it. The next chapter stays in India and looks at how a failed harvest became a famine that killed millions, and at the relief that was offered, which in too many cases was not relief at all. By the second year of failed rain, the dying in India had become a catastrophe measured in the millions. The estimates that historians have reconstructed for this single famine, the one centred on southern India, run between roughly 6 and 10 million deaths. One careful recent study lands near 8 million. These are not casual figures. They come from comparing the population that should have existed with the population that census takers actually found afterward, and counting the enormous gap between them. Behind every point on that range are real people who starved in a specific place and time. A government did respond, and it is important to be fair about that. Relief works were set up, projects where the starving could labour in exchange for food, and over the course of the crisis the authorities relieved hundreds of millions of what they counted as person days of hunger, and spent a large sum doing it. On paper, a system existed. The tragedy lies in how that system was designed, and in the ideas about money and human worth that shaped it. The men who ran the relief were guided by a belief that aid should be given as grudgingly as possible, for fear that generosity would make the poor dependent or waste public money. So the terms were made hard on purpose. In one notorious arrangement, a labourer at a relief camp received a daily ration of grain that came to only about £1, in exchange for a full day of heavy work moving earth, often with no shade and no rest, sometimes after a long walk to reach the camp at all. Doctors of the day noted that this ration was less than what was later thought necessary to keep a person alive under hard labour. The relief, in other words, could starve you slowly while you worked for it. The reasoning behind this cruelty was not personal malice, which in a way makes it harder to look at. It was ideology. The officials in charge held firmly to a school of economic thought that treated the free market as something close to sacred, and that regarded interference in it, even to feed the dying, as a dangerous error. If grain was expensive because it was scarce, the thinking went, then the market was simply doing its work, and to give food away freely would only distort it. This is the belief that shaped the response, and it was applied to a starving population with a terrible consistency. The most bitter fact of the Indian famine is what happened to the grain that did exist. Even in the worst years, India as a whole was still growing food, and it was still exporting food, shipping wheat out of the country to distant markets while its own people starved on the roads. The harvest had failed in the drought-struck regions, but the country was large, and grain moved by rail toward the ports rather than toward the hungry, because the ports was where it sold. A land that was exporting food watched millions of its own die of hunger. That is not a paradox of nature. It is a result of choices. There were people at the time who saw it clearly and said so. Journalists and reformers described what they were witnessing in plain and furious terms, and warned that history would judge the response as a stain that would outlast the empire that produced it. Their accounts are part of how we know the story in such detail. The crisis was not hidden. It was reported, argued over and defended by those in charge, who mostly held to their principles as the death toll climbed. It would be a mistake to imagine that a wiser response could have made the drought harmless. The rains had failed across an enormous area, and some hardship was unavoidable no matter what anyone did. But the distance between hardship and catastrophe, between a hungry year and 8 million dead, is vast, and much of that distance was filled by human decisions. A different set of choices, a willingness to hold grain at home, to feed rather than to make the starving labour for less than a survival ration, would have left far fewer graves. This is the pattern to carry forward, because it repeats. In each of the 3 great drought zones of this era, the sky supplied the failure, and the rulers supplied the scale. India was the first and among the largest, but it was not alone. Across the mountains and the sea, in northern China, the same failed rains were producing a famine of their own, one whose numbers may have been larger still. That is where the story goes next. While India was dying under a failed monsoon, the same ocean pattern was starving the far side of Asia. In the north of China, across a cluster of provinces inland from the coast, the rains failed across the same stretch of years, and the drought there settled in with a ferocity that some accounts rank as even deadlier than India's. The famine that followed is remembered in Chinese history as one of the worst the country ever endured, and its death toll may have exceeded everything happening in India at the same moment. The estimates for the northern Chinese famine run high, commonly placed somewhere between 9 and 13 million deaths, spread across several provinces over about 3 years. As with all figures from this era, they are reconstructions carrying real uncertainty, built from imperial records and later study rather than from anything like a modern census. But the order of magnitude is not in doubt, an immense number of people died in a concentrated region over a short span of time, from the same root cause that was emptying the Indian countryside. The geography of northern China made the drought especially cruel. Much of the affected region is high, dry farming country to begin with, dependent on modest seasonal rain and on rivers fed from far away. When the rains failed there, the land had little margin to give. The loess soil of the region, fertile when watered, turned to dust when it was not. Whole districts that had grown enough to feed themselves in a normal year found that in the drought there was simply nothing, and the nearest surplus was hundreds of miles away over difficult ground. That distance was the killer as much as the drought itself. In the 1870s, the interior of northern China had few good roads and no railways to speak of across the worst-hit areas. Even where grain existed elsewhere in the empire, moving it to the starving districts meant hauling it overland by cart and pack animal, along tracks that turned treacherous, slow work that could not keep pace with the scale of the need. Relief that might have saved a region could not physically reach it in time. The land that was supposed to be saved was walled off by its own remoteness. The government of the day did attempt to respond, organising relief and moving what grain it could, and some officials worked with real dedication against impossible odds. But the empire was already strained, weakened by decades of internal upheaval and by earlier conflicts that had drained its strength and its treasury. A state that is already exhausted has little in reserve when a disaster of this size arrives. The machinery of relief existed, but it was too small, too slow, and too far from the need to turn the tide. Here again, the deeper lesson holds, though it wears a different face than it did in India. In India, food existed and was carried away by policy. In northern China, the failure was more one of reach, and of a state stretched past its limits, unable to bring help across the distance in time. The particular reasons differ. The underlying truth is the same. The drought created the shortage, but whether that shortage became a massacre depended on the human systems around it, on their strength, their speed, and their priorities. It is worth sitting for a moment with what it means that these two catastrophes were happening at once, thousands of miles apart, without either side fully grasping that they shared a cause. To the people of the Deccan, and to the people of northern China, the disaster felt like a local curse, a failure of their own particular sky. Neither could have known that the same warm patch of far-off ocean was behind both, tilting the rains away from each of them in the same season. The connection was invisible to everyone living through it. That hidden connection is one of the most important things this whole story has to teach, and we have not yet followed it to its third corner. The same pattern that dried out southern India and northern China had also reached across the world to South America, to the northeastern shoulder of Brazil, where a drought of its own was underway. 3 continents, 1 ocean, 1 linked catastrophe. The Brazilian chapter of it is where we turn next. The third great drought of this era struck the northeastern corner of Brazil, a region known as the Sertão. It is a semi-arid land at the best of times, a place of scrubby brush and thin soil where farmers and herders have always lived close to the edge of what the rain allows. The people there had a name for the disaster when it came. They called it the Grande Seca, the Great Drought, and it remains one of the defining catastrophes in the history of that part of the country. The drought took hold across the same stretch of years that was punishing Asia, and in the Sertão it was near total. The seasonal rains that the region depended on simply did not arrive, and the land, never far from dry, cracked and emptied. Rivers that were seasonal to begin with vanished entirely. Cattle, which were the backbone of the region's economy, and a family's stored wealth on the hoof, died in enormous numbers as the pasture turned to dust. When the animals were gone, the people had lost both their food and their savings in one stroke. The death toll in Brazil is usually estimated at around 500,000 people, smaller than the counts in India or China, but devastating against the population of that region, which was far smaller to begin with. A loss of 500,000 from the northeast meant that a large share of everyone living there died or fled. In proportion to the people at risk, the Grande Seca cut as deep as anything happening on the other side of the world. The smaller raw number hides a wound that was, for that region, total. What happened to the survivors shaped Brazil for generations. As the Sertão emptied, enormous numbers of people abandoned it, streaming toward the coast and the cities in search of food and work and water. Some went to the growing port towns. Later waves of drought migrants would help feed the rush into the Amazon for the rubber boom. This flight from the dry interior became a permanent feature of Brazilian life, a pattern of migration set in motion by the droughts of this era and repeated in the dry years that followed. The Grande Seca did not only kill, it moved a people and remade a map. The response to the Brazilian drought carried its own hard lessons, echoing the failures seen elsewhere. Relief was slow, poorly organised, and tangled in the interests of powerful landowners and local politics. Aid that was meant for the starving was diverted and delayed. Crowded relief camps and disease-ridden shelters became places where the gathered refugees died of epidemics as much as of hunger, the sickness spreading fast through weakened people packed together. Once again, the drought opened the door, and the human response determined how many walked through it to their deaths. Set the three regions side by side, and the shared shape becomes impossible to miss. In India, food existed and was exported while people starved. In northern China, food could not reach the starving across a vast and roadless distance. In Brazil, relief was captured by the powerful and the gathered poor died in camps. The particular failures were different in each place, rooted in each society's own structure. The common thread running through all three was that a natural shortage met a human system that failed to protect the vulnerable, and the result each time was mass death. And behind all three, tying them into a single event across three continents, was the one warm ocean in the middle of the Pacific. This is the fact that turns three regional tragedies into one global one. The people of the Sertão, like the farmers of the Deccan and the north of China, experienced their drought as a local fate. It was not local, it was one arm of a single planetary pattern, reaching out to dry three widely separated lands in the same seasons. Having seen each corner of the disaster on its own, we can now step back and look at the whole. How does one patch of warm water in one ocean reach across the entire globe and pull the rain away from three continents at once? The mechanism that links them is the subject of the next chapter, and understanding it is what lets us connect that old catastrophe to the warm Pacific of today. The question that ties this whole history together is a physical one. How does warmth in a single ocean reach across the world and dry out three continents in the same seasons? The answer is that the atmosphere is not a set of separate local weather systems sitting side by side. It is one connected fluid, wrapped around the whole planet, and a large enough disturbance in one part of it sends ripples through all the rest. El Niño is a large enough disturbance. Start again with the rain belt that shifts east during El Niño. When the heaviest tropical thunderstorms move out over the central Pacific following the warm water, they do not simply relocate quietly. That towering column of rising warm air is like a boulder dropped into a stream. It sets up waves in the flow of the upper atmosphere, waves that travel far downstream from the disturbance itself. These waves nudge the position of the high-altitude winds and the great semi-permanent zones of high and low pressure that steer weather across the globe. Follow those ripples outward, and you can trace how the effects land in distant places. Over India, the shifted circulation tends to weaken the monsoon, pulling the reliable summer rains toward failure. Over parts of Africa and northeastern Brazil, the changed pattern of rising and sinking air suppresses the rain that those regions depend on. The same disturbance that soaks the central Pacific starves the edges, and the edges can be a hemisphere away. The connection is real, physical, and traceable, even though no one standing in a dry field could ever have felt the link. In the 1870s event, this reach was amplified by a companion pattern in a second ocean. Around the Indian Ocean, the temperatures on the eastern and western sides can fall out of their usual balance, a seesaw that scientists now track as its own index. In that catastrophic stretch, the Indian Ocean pattern lined up in the way that deepens drought over southern Asia, working alongside the Pacific El Niño rather than against it. When two ocean patterns push the same direction at once, the drought they produce is worse than either would cause alone. That alignment is part of why the old event was so severe. There is a lesson in that pile-up that matters for reading any event, including the current one. These patterns do not act in isolation. The Pacific, the Indian Ocean, the state of the North Atlantic, and the slow baseline warming of the whole planet all play at the same time, and their effects can add together or cancel out. A very strong El Niño landing at the same moment as other patterns pushing the same way is far more dangerous than the same El Niño landing when the others push back. Judging a real event means watching the whole board, not one square of it. This connectedness cuts in a hopeful direction too, and it is worth saying so plainly. Because the atmosphere is one linked system, and because a strong El Niño leaves such a distinctive signature, its effects are among the most predictable in all of climate science. Forecasters cannot tell you what the weather will do next Tuesday in a given town, but they can tell you, months ahead, that a strong El Niño tilts the odds toward a drier monsoon here and a wetter winter there, because those connections hold across event after event. The same physics that spread the old disaster is what lets us see the new one coming. That is the deep difference between the 1870s and today, and it does not lie in the ocean. The Pacific behaves now much as it behaved then, following the same rules of wind and water and heat. The warm patch forming today is the same kind of thing as the warm patch that formed 150 years ago. What has changed is entirely on the human side, in what we can see and what we can do about what we see. The ocean has not learned anything, we have. So we arrive at the true heart of this history, the point that everything so far has been building toward. The 1870s drought killed tens of millions of people, and the drought itself was only half the reason. To understand the disaster fully, and to understand why the same ocean pattern today need not repeat it, we have to look squarely at the other half. The next chapter takes up the hardest and most important part of the whole story, the human decisions that turned a failure of rain into a failure of survival. Here is the fact that the whole history turns on, stated as plainly as it can be. The 1870s drought did not have to kill the number of people it killed. The failure of the rains destroyed harvests across 3 continents, and that alone would have brought hardship and hunger anywhere it struck. But the leap from hunger to the deaths of tens of millions was not made by the weather. It was made by people, through the systems they had built and the choices they defended. The historian who did the most to press this point gathered the evidence into a single hard argument. He looked at all 3 great drought zones together, and showed that in each one, food or the means to buy it existed somewhere within reach, and that in each one, the way society was organized kept that food from the starving. In India, grain was exported while people died. In China, a strained empire could not carry relief across the distance in time. In Brazil, aid was captured by the powerful and the gathered poor perished in camps. The drought was the trigger. The social order pulled it. The clearest and most damning case is the one already touched on in India, because there the food was right there and moving the wrong way. A country in the grip of famine went on shipping wheat out to foreign markets, because the rules that governed that country treated grain as a commodity to be sold to the highest bidder, not as the survival of the people who grew it. The market was allowed to decide who ate, and the market decided in favour of distant buyers with money over local people with none. That was a choice, made and defended by men who believed it was the correct one. It is important to name what that belief was, because it was not simple cruelty or indifference. It was an ideology, a coherent set of ideas about economics that its holders considered wise and even moral. They believed that the free market should not be interfered with, that charity to the poor did more harm than good, and that a population suffering in a famine was, in some cold sense, a natural correction that it would be a mistake to soften. Armed with that conviction, sincere men presided over mass death and told themselves they were being responsible. That is more chilling than malice, and more instructive. None of this means the drought was harmless, or that better policy could have erased it. That would be its own kind of falsehood, and this report will not trade one distortion for another. The rains failed across an enormous area for years, and in the technology of that century some real suffering was unavoidable no matter who was in charge or what they believed. The honest claim is narrower and stronger than saying the disaster was purely man-made. It is that the gap between unavoidable hardship and the actual catastrophe, the gap between a hard year and tens of millions dead, was very wide, and human decisions filled most of it. This is why the number in the title, real and enormous as it is, must be understood rather than simply feared. If tens of millions died purely because the ocean warmed, then the warm ocean forming today would be a sentence of doom, and there would be little to do but brace. But that is not what the record shows. The record shows a natural shock passing through human systems that failed to protect people, and failed in ways that were specific, identifiable, and in principle avoidable. The ocean set the test. The societies of the day mostly failed it. That reframing changes everything about how we should read the present. The right question to ask about the El Niño forming now is not only how warm the Pacific will get, it is also what kind of systems that warmth will pass through when it arrives on land. Are the vulnerable regions of today protected or exposed? Can food and aid reach the people who need them? Are the ideas that guide the response ones that will feed the hungry, or ones that will let them starve on principle? Those are the questions that decided the outcome last time, and they will do much to decide it again. We now have both halves of the old disaster in hand, the natural shock and the human failure that multiplied it. That complete picture is the tool we needed. In the next chapter, we take the lesson it offers and turn back toward the present, toward the warm Pacific of today and the very different world it is forming over, to begin asking how much of that grim history still applies and how much of it we have left behind. Two threads have run side by side through this report so far. One is the warm Pacific forming now, watched by satellites and named in an advisory. The other is the warm Pacific of a century and a half ago, reconstructed from tree rings and census gaps, and the accounts of people who lived through its aftermath. We have followed the old event all the way to its hardest lesson. Now the two threads meet, and the meeting point is where the rest of this report will live. The lesson the dead of the 1870s left behind can be stated in a single sentence. A natural shock becomes a human catastrophe only through the human systems it passes through. The drought was the same across 3 continents, but the death it caused depended on exports and railways and ideology and the strength of a state, on all the human machinery standing between a failed harvest and a fed family. Change that machinery, and you change the outcome, even if the weather is identical. This is the most useful thing the whole terrible history has to teach. That lesson is, at bottom, a hopeful one, and it is worth being clear about why. It means the tens of millions of deaths were not written into the physics of El Niño. They were written into the world of that time, its empires and its economics and its limits, and that world is gone. A warm Pacific does not carry a death toll the way a bullet carries a wound. It carries a shock, and what that shock does depends on where it lands and on how ready that place is to absorb it. Readiness is something a society can build. That is the whole of the good news, and it is not small. But the lesson cuts both ways, and honesty requires holding both edges. If the old deaths were not fated, neither is safety today fated. The same sentence that frees us from the ocean's determinism also puts the responsibility squarely on human systems, and human systems can still fail. A region left exposed, an aid network cut back, a return to the belief that the market alone should decide who eats, any of these could let a modern drought cut deeper than our tools should allow. The physics has been tamed by knowledge. The human half has not been tamed by anything, and it never fully will be. So the question this report has been building toward can finally be asked in full. The Pacific is warming now toward a level it may not have reached since that catastrophic event. The ocean part of the story is genuinely comparable. What about the other part? What kind of world is this warmth forming over? How much stronger are our defences than the ones that failed so badly last time? And where are the weak points that a strong El Niño could still find? Those questions are the work of the second half of this report. We will take them in order. First, we will return to the ocean itself and look hard at where the current readings stand and how, as best we can tell, they compare to the old extreme. Then we will follow the warmth outward the way we followed it in the history, tracing where the rain will move, where the heat will build, which parts of the world get too little water and which get too much. We will look at the quieter effects too, including one region that a strong El Niño tends to calm rather than harm. And then we will come to the part that matters most, the human map. We will ask who is exposed now and who is not, and the answer will surprise anyone who assumes it is the same regions as before. The lands that suffered most in the 1870s are, for the most part, far better protected today, which is the clearest proof that the lesson can be learned. The real worries have moved to other places and to other questions, including whether the systems built to catch a falling region will be there when the falling starts. That is the road ahead. We leave the graves of the 1870s behind now, not because they are finished teaching, but because we have taken the lesson they hold and can carry it forward into the present. The warm water is still building out in the Pacific as this is written. It is time to turn back to it, to read what it is doing today, and to measure the distance in both directions between now and the last time the atmosphere acted like this. turn back to the water and read what it is doing right now. In the Central Pacific, the patch that forecasters watch most closely has crossed the line into El Niño and is climbing. In the Eastern Pacific, nearer South America, the surface is already running warmer than average by around 3.5 to 4 degrees Fahrenheit, which is a strong reading this early in the event. The heat that had been pooling beneath the surface has surfaced, and the ocean is loading toward the top of the scale rather than easing off. The forecast for where it goes from here is firm in its direction. The models agree that the warmth will keep building through the second half of the year and peak in the northern winter, most likely between December and February. That timing is normal for El Niño, which almost always reaches its full strength in the winter months regardless of when it first forms. What is less normal is the projected height of the peak. The central estimate points toward the very strong category, and the more aggressive outlooks push higher still. Set that against the old event and be honest about the limits of the comparison. The 1870s El Niño is reconstructed from indirect evidence, from corals and tree rings and scattered records, not from anything like the instruments we have today. That means any ranking of it against a modern event carries real uncertainty, and careful scientists say so rather than pretending to a precision they do not have. The most we can responsibly claim is that the old event was very likely the strongest reconstructed, and that the current one is forecast to reach a level that, in the modern record, only a handful have touched. So the fair statement is a careful one. The Pacific today is warming toward the same neighbourhood, in raw ocean terms, that it reached in that catastrophic stretch. We cannot say the two match exactly, because we cannot measure the old one precisely enough to make that claim. But the current event is large enough, and forecast to grow large enough, that the comparison in the title is not an exaggeration on the ocean side. The warm water really is doing something it may not have done at this scale since then. There is one more measurement worth holding in mind, and it changes the meaning of everything else. The whole planet is now warmer than it was in the 1870s, by well over 2 degrees Fahrenheit on average, from the long build-up of heat-trapping gases in the air. An El Niño of a given ocean strength therefore lands on a hotter world than the same event would have then. The extra warmth it adds stacks on top of a raised floor, which means that even a matched ocean anomaly can push temperatures and heat stress to levels the old event never reached, purely because the starting point is higher. That is a genuinely new element, and it deserves to be named without alarm and without minimizing. The people of the 1870s faced a drought pattern on a planet near its long-term average temperature. The people of today face a comparable pattern on a planet that has already warmed substantially. The drought risk from the shifting rain belt is the old, familiar danger. The added heat and what it does to water supplies and crops and human health is a danger the old event did not carry in the same measure. We are running a similar experiment on a warmer stage. None of this tells us yet what it will mean for people, and it is important not to jump ahead of the evidence to a conclusion. A warm ocean and a hotter baseline describe the shock. They do not describe the outcome, because the outcome depends on where the effects land and how ready those places are, which is the human question the whole second half of this report is built around. The ocean reading is the input. It is a large input. It is not, by itself, a forecast of suffering. What the current reading does establish is that this event is worth the careful attention it is getting. The comparison to the deadliest drought in modern history is not clickbait laid over a minor wobble in the Pacific. It rests on a real and building warm anomaly, forecast toward a rare category, landing on a warmer world. That is the solid ground the rest of the report stands on. Before we follow the warmth outward to the land, it is worth understanding how we can see all of this so clearly in the first place, because the seeing is the single greatest thing that separates now from then. The most important difference between this event and the one in the 1870s is not in the ocean. It is in our ability to watch the ocean. 150 years ago, the warm water that would help kill tens of millions of people surfaced in the Pacific entirely unseen. No one measured it, no one named it, and no one connected it to the failing rains half a world away. The disaster arrived without warning because there was no one and nothing positioned to give one. That is the gap that modern science has closed, and it is worth understanding how. The watching happens on several levels at once. Anchored across the equatorial Pacific is an array of buoys, floating instruments moored to the sea floor that measure the temperature of the water at many depths and beam the readings back by satellite in near real time. These are what let forecasters see the warmth building beneath the surface months before it rises into view, the early tell that an El Niño is on the way. The buoys turn the ocean's hidden interior into something we can read like a gauge. Above them, satellites add a second layer of sight. Some measure the temperature of the sea surface across the whole basin at once, painting the warm and cool patches in a way no ship-by-ship survey ever could. Others measure the height of the sea surface itself, because warm water expands and stands slightly higher, so a map of sea level becomes another map of where the heat is. Together, the satellites give a complete, refreshed picture of the entire tropical Pacific every few days, the kind of God's eye view that would have seemed like magic to the forecasters of the past. Then those measurements feed the third layer, the models. A modern climate model takes the current state of the ocean and atmosphere and runs the physics forward in time, calculating how the warmth will spread and how the winds will respond. Many different teams around the world run their own models, built on different assumptions, and forecasters look at all of them together. When 24 independent models point the same direction, as they have this year, the agreement itself is a form of confidence that no single forecast could provide. This whole apparatus is why an advisory can arrive months before the strongest effects, rather than as an autopsy afterward. It is why regions that El Niño tends to dry out can be told, well ahead of the season, that their odds of a poor rainfall year have risen, giving governments and farmers and aid agencies time to prepare. The lead time is the gift. In the 1870s, the drought was upon people before anyone understood it. Today, the shape of the risk can be seen forming from a season away. It is worth being clear about what this forecasting can and cannot do, so that its value is neither overstated nor dismissed. It cannot tell a specific town what its weather will be on a specific day. El Niño does not work like that. What it can do is shift the odds and say so honestly, telling a region that a drier or wetter season is more likely than usual, by a certain margin, with a certain confidence. That is a probabilistic warning, not a promise. And used well, it is enormously powerful. A farmer who knows the odds have tilted toward drought can plant differently. A government that knows can preposition food. Odds, acted on early, save lives. The measurement also lets us do something the people of the past could never do, which is to compare events and learn from the pattern. Because we have clean records back to about 1950, forecasters can look at how past strong El Niño actually played out, region by region, and use that history to sharpen the current outlook. The 5 very strong events of the modern record are a library of examples. Reading them is part of how the impacts of the one now forming are being anticipated. All of this site is the foundation for everything that follows, because you cannot prepare for what you cannot see. Having established that we can watch this event in a way the old world could not, we can now follow the warmth outward from the ocean and onto the land with real confidence, tracing where it is expected to push the rain away and where it is expected to pile the rain up. That map of coming wet and dry is where the effects begin to touch human life, and it is where we turn next. Now follow the warmth onto the land and watch the rain move. The single most consequential thing a strong El Niño does is redraw the map of where rain falls, and forecasters can already sketch that redrawn map for the season ahead. The general rule is the one established earlier. The rain belt slides toward the central Pacific, and around the edges of the world certain regions go dry while others get soaked. The specifics of which regions are the whole practical meaning of the event. On the dry side of the ledger, the outlooks for this event flag several familiar zones. Large parts of Southeast Asia and the maritime continent, the belt of islands around Indonesia, tend toward drought during a strong El Niño, because the rain that normally sits over them has shifted east. Eastern and southern Africa carry raised drought risk. Northern and eastern Australia often turn dry and hot. Parts of Central America and northern South America lean drier as well. And the monsoon lands of southern Asia, India above all, face the elevated risk of a weaker seasonal rain, the very failure that opened the catastrophe of the 1870s. On the wet side, the same shift that starves some regions drowns others. The southern tier of the United States tends toward a wetter, stormier winter as the high-altitude winds shift south and steer storm after storm across California and the Gulf states. Parts of the dry coast of South America, in Peru and Ecuador, can see extraordinary rainfall and flooding, a cruel irony in lands that are normally arid. East Africa's shorter rains can turn heavy. The water did not leave the planet, it relocated, and the relocation is what each region experiences as either a drought or a flood. The timing of all this follows the ocean. The effects build as the El Niño strengthens through the second half of the year and peak in the northern winter, roughly December through February, with some of the drought risk in the tropics beginning to bite as early as September and persisting into the following spring. This is a season-scale event, not a single storm. Its consequences unfold over months, which is both what makes it dangerous, because a whole growing season can fail, and what makes it manageable, because the long build-up leaves time to prepare. It is important to hold these outlooks at the right level of certainty, and the honest level is that these are shifts in the odds, not guarantees. Every El Niño imprints its own particular pattern, and the general tendencies do not play out identically each time. A region flagged for elevated drought risk is more likely than usual to have a poor rainfall season, but it is not certain to. Forecasters state these outlooks as probabilities on purpose, and reading them wisely means treating them as raised risks to prepare for rather than fixed fates to dread. Notice, though, how much power sits in even a probabilistic map like this. The people of the 1870s had nothing of the kind. The drought fell on India and China and Brazil as an unforeseen calamity, region by region, each place blindsided in its own season. Today the regions most likely to be hit can be named a season in advance, from a warm patch of ocean thousands of miles away. That foresight, if it is used, is the difference between being caught unaware and being ready. The map exists this time before the season does. There is a pattern worth noticing in that list of at-risk regions, and it points toward the report's later chapters. Some of the places flagged for drought this year, in Eastern Africa and the Sahel and parts of Southern Asia, are among the more vulnerable in the world, places where a failed harvest strained systems that are already strained. Others, like the southern United States facing a wet winter, are wealthy and well defended and will treat the event as an inconvenience and a flood risk rather than a threat to survival. The same ocean, the same physics, and utterly different human stakes depending on where the warmth lands. That is the reason a map of rain is not yet a map of suffering, and why we cannot stop at the weather. Before we reach the human map, though, there is a second physical effect to account for, one that rides alongside the shifting rain, and that this warmer age has sharpened. Beyond moving water around, a strong El Niño reaches up and lifts the temperature of the entire planet for a while. That extra heat, where it comes from, and when it will peak, is the next piece to understand. Beyond moving the rain around, a strong El Niño does something to the whole planet at once. It warms it. For a stretch of roughly a year, the average temperature of the entire Earth rises, and a strong event can push it to a record high before the warmth fades. Understanding where that heat comes from, and why it is temporary, matters for reading what this particular event will do to a world that is already hotter than it used to be. The heat has been hiding in the ocean. Over the years of the cool phase that preceded this event, when the trade winds blew hard, warm water was piled up and pressed down into the western Pacific, storing heat below the surface out of contact with the air. That stored heat is a kind of reservoir filled slowly over the quiet years. When El Niño arrives and the warm water spreads across the surface of the basin, that reservoir is opened. The heat that had been locked beneath the surface is released into the atmosphere, and the whole planet feels it. This is why forecasters sometimes describe a strong El Niño as a temporary warming of the globe, a brief release of heat the ocean had been banking. The effect is real but limited in size and time. A strong event adds somewhere on the order of a few tenths of a degree Fahrenheit to the global average for about a year, and then the heat dissipates and the temperature settles back. It is a spike, not a staircase. The El Niño does not create new heat so much as move stored heat from the ocean into the air, where it shows up on the thermometer for a while before radiating away. The timing follows the ocean as everything else does. The global temperature bump tends to lag the peak of the El Niño by a few months, so a winter peak in the Pacific often shows up as a run of unusually warm months worldwide stretching into the following year. During the last very strong event, the year that followed its peak set a global temperature record. A similar pattern is plausible with this one, which means the warmest months on the global record could well arrive during and just after this event's peak in the coming winter and the spring beyond it. Here is where the warmer baseline changes the stakes, and it is the crucial point of this chapter. The El Niño's few tenths of a degree do not land on the cool world of the 1870s. They land on a world that has already warmed by more than 2 degrees Fahrenheit from human activity. The two add together. The temporary spike from the ocean stacks on top of the permanent rise from heat-trapping gases, and the sum is what people actually live through. A given El Niño therefore delivers more dangerous heat today than the identical event would have in the past, simply because it starts from a higher floor. What that added heat does on the ground is the part that touches lives. Higher temperatures deepen droughts by pulling moisture faster out of soil and crops and reservoirs, so the dryness from the shifted rain belt is made worse by the warmth layered over it. Heat itself becomes a direct danger to health, especially in the tropics and subtropics where the extra warmth is expected to build from late in the year and hold into the following spring. The combination of a failed rainy season and unusual heat is harder on a farming region than either would be alone, and this event threatens to bring both to some of the same places. It is worth keeping the scale of this honest and steady, rather than letting the word record do dramatic work it should not. A record global temperature is a genuine signal that the planet is warm, and it deserves to be taken seriously. It is not, in itself, a catastrophe, and the extra heat from this event will be measured in fractions of a degree on the global average, not in some sudden lurch. The danger is specific and local, felt as worse drought and higher heat stress in particular vulnerable regions, rather than as a uniform disaster everywhere. Precision about that keeps the concern where it belongs, so the physical picture of the event is nearly complete. The rain is shifting, drying some regions and drenching others, and the whole is running hotter because of the heat the ocean is releasing onto an already warm world. Before we assemble the human map from all of this, it is worth turning to a part of the story that runs the other way, a place where this same strong El Niño is expected to calm a danger rather than sharpen one. That quieter effect over the Atlantic is the next piece. Not everything a strong El Niño does is a threat, and honesty requires giving the calmer side of the ledger its due. There is at least one major hazard that a strong El Niño tends to suppress rather than worsen, and it is a significant one. Over the Atlantic Ocean, where hurricanes are born, a strong El Niño makes the season quieter than it would otherwise be. For the millions of people who live along the Atlantic and Gulf coasts, that is a real and welcome effect, and it is already showing up in this year's forecasts. The mechanism is worth understanding because it shows how the Pacific's reach truly spans the globe. When the rain belt shifts east during El Niño, it changes the high-altitude winds all the way across to the Atlantic. Specifically, it increases what forecasters call wind shear over the tropical Atlantic, which means the winds high up blow at a very different speed and direction than the winds near the surface. Hurricanes need a calm, aligned column of air to grow tall and organized. Strong shear tears at a developing storm, ripping the top away from the base before it can build into anything dangerous. A strong El Niño floods the Atlantic with exactly that disruptive shear. The effect on this season is already visible in the numbers. A leading hurricane research group lowered its forecast for the Atlantic season, cutting the expected number of named storms and predicting activity well below the long-term average, citing the strengthening El Niño as the reason. Early in the season, the tropical Atlantic was notably quiet, with the shear from the Pacific pattern already suppressing the storms that might otherwise have been forming. The forecast is for a calmer than normal year of Atlantic hurricanes, and the El Niño is the direct cause. This is a genuine benefit, and it should be counted honestly alongside the risks, because a fair report does not hide the good news to keep the mood grim. A quiet hurricane season means fewer of the storms that in an active year can kill people and cause enormous damage along the American coast, in the Caribbean, and in Central America. Weighed against the drought risk that the same event brings elsewhere, the suppressed hurricane season is one of the clearer places where a strong El Niño makes a part of the world safer rather than more dangerous. The pattern gives with one hand as it takes with the other. There is a mirror to this that keeps the picture balanced. While El Niño calms the Atlantic, it tends to energize the tropical storms of the Pacific, where the warm water and favorable winds can support more and stronger systems. Storm activity, in a sense, shifts basins along with the warmth, quieting where the shear rises and stirring where the water warms. The total danger from tropical storms is not so much erased as moved, which is a theme this whole report keeps returning to. El Niño rearranges the hazards of the world more than it simply adds to them. It is worth resisting the temptation to let this good news cancel the concerns raised elsewhere, because they are not the same coin. A quieter Atlantic hurricane season is a real gift to the people it protects, and it stands on its own. It does nothing, however, to feed a farming region whose monsoon has failed on the far side of the world. The benefit and the risk fall on different places and different people, and one does not offset the other in any way that a family facing a dry season would recognise. The good news is true, and the hard news is also true, and both belong in an honest accounting. Keeping both in view is exactly the calm, complete picture this report is trying to hold. A strong El Niño is not a single disaster bearing down on everyone alike. It is a global rearrangement, dangerous here, protective there, hotter almost everywhere, and the fair way to describe it is to name each effect where it lands rather than to paint the whole event one colour. We have now seen it dry some regions, wet others, warm the planet, and calm the Atlantic. There is one more physical effect to place on the map before we turn fully to people, and it is the opposite of drought. It is the water that comes too fast, the flooding on the wet side of the world, and that is where we go next. For all that this report has dwelt on drought, following the old catastrophe, a strong El Niño is just as much a story of too much water as of too little. On the wet side of the shifted rain belt, whole regions can be swamped, and the flooding that results is its own distinct danger with its own distinct victims. To picture the event fairly, the flood map has to sit beside the drought map, because both are the same shifted rain seen from opposite edges. The most dramatic flooding often strikes the very coast where El Niño was first named. Along the normally arid shores of Peru and Ecuador, the warm water that pools against South America during a strong event feeds torrential rain over land that is usually desert. Rivers that are dry most of the year fill and burst. In past strong events, this stretch of coast has seen catastrophic floods and landslides, roads and bridges swept away, whole neighbourhoods inundated in a place that sees almost no rain in an ordinary year. The same warm water that starves Asia of rain can drown the Peruvian coast. Other regions face their own version of the wet extreme. The southern United States from California across to the Gulf tends toward a stormier, wetter winter as the storm track shifts south, which can mean flooding rivers and saturated ground and heavy mountain snow across the season. Parts of eastern Africa can see their rains turn unusually heavy, flipping a drought-prone region into a flood-prone one within the same event. The physical rule underneath is always the same. Wherever the rain belt has newly settled, the water arrives in excess, and excess water is as capable of killing as its absence. Flooding kills differently than drought, and quickly, which is worth understanding plainly. A drought is slow, unfolding over a season, giving at least the possibility of warning and response. A flood can arrive in hours. Flash floods sweep people away, landslides bury homes on steep ground softened by days of rain, and standing water left behind breeds the diseases that follow a flood as surely as they follow a famine. The danger is fast and physical where drought is slow and grinding, but the shared root is the same relocated rain. There is a hard compounding in the fact that a single event can bring both disasters at once to a single country. A large nation can find its northern region parched while its southern coast floods, both in the same season, both driven by the same warm ocean. Relief efforts that might handle one crisis can be stretched past breaking by two at opposite ends of the country. This double burden is part of what makes a strong El Niño so demanding on the systems meant to respond to it. It does not present one clean problem. It presents several at once in different places, pulling in different directions. As with every effect in this report, the honest framing is that these are elevated risks rather than certainties, and preparation turns on reading them that way. A region flagged for flooding is more likely than usual to see dangerous rain, not guaranteed to. But the same foresight that lets a drought-prone region prepare its food supply lets a flood-prone region clear its drains, ready its shelters, and warn the people living in the path of the water. The forecast is a chance to act, and flooding, precisely because it can arrive so fast, is a hazard where acting early on a raised risk saves the most lives. Stepping back, the full physical portrait of the event is now in place. The warm Pacific shifts the world's rain, drying some regions toward drought and drenching others toward flood, while lifting the planet's temperature and quieting the Atlantic storms. That is what the ocean does. What none of it settles is the question that has run underneath this report from the start, which is what all of this means for people. A shifted rain map and a flood map are maps of physics. To turn them into a map of human consequence, we have to ask how these shocks reach ordinary life, and the clearest thread to follow is the one that runs from the ocean to the food we eat. That thread is next. To see how a warm ocean reaches an ordinary life, follow the food. The most direct line between the Pacific and a person who never thinks about the Pacific runs through agriculture, because the regions El Niño dries and floods are very often the regions that grow the world's crops. When the rain belt shifts, harvests shift with it, and the effects ripple out from the field to the market to the dinner table, sometimes half a world away from the drought that started them. The reach across crops is wide because the at-risk regions grow so much of what the world eats. A strong El Niño can hurt rice and palm oil across a drying Southeast Asia, wheat in a parched Australia or India, coffee and sugar in affected parts of Brazil, corn and other staples across drought-struck stretches of Africa and Central America. Because these effects strike different crops in different regions all in the same season, the event can press on the global food supply from several directions at once, rather than through any single failed harvest. The pressure is broad rather than narrow. The consequence shows up as price, and price is how the distant drought reaches a household that had a fine growing season of its own. When a major producing region has a poor harvest, the supply of that crop tightens on the world market, and the price rises for everyone who buys it near and far. Forecasters looking at this event have flagged particular concern for certain grains, warning that prices for some staples could climb sharply if the event reaches its stronger scenarios. A family that buys imported grain can feel a Pacific drought in the cost of its bread without a single dry day in its own sky. This is the same mechanism seen from the other side that made the 1870s so lethal, and the echo is worth naming carefully. In that catastrophe, grain was a commodity whose price and movement were governed by distant markets, and that governance carried food away from the starving toward those who could pay. The global food market can spread a shortage's pain across the whole world through price, and it can pull food toward money and away from need. The market is a powerful machine for moving food efficiently, and its indifference to who can pay is exactly the danger the old disaster exposed. But the differences today are as real as the echo, and they cut towards safety, so the comparison must not be left one-sided. The global food system now is vastly larger, more diverse, and better connected than the one of the 1870s. A poor harvest in one region can be offset by a good one elsewhere, carried quickly by modern transport to where it is needed. Grain reserves exist, early warning systems track harvests, and flag looming shortfalls a season ahead. International bodies stand ready to move food aid into regions facing famine. The machinery for cushioning a food shock is incomparably stronger than anything that existed then. So the honest picture of the food risk is layered rather than simple. A strong El Niño will very likely tighten global food supplies and push some prices up. And for the world's poorest people, who spend the largest share of their income on food, even a price rise can push a precarious household toward hunger. That is a genuine hardship, and it should not be waved away. At the same time, the systems that turn a price rise into mass starvation, the ones that failed so catastrophically last time, are far stronger now, and a modern food shock is far more likely to mean strained budgets and hungry months than the emptying of whole regions. That layering points straight at the question the whole second half has been circling, because it locates the real risk not in the harvest, but in the household, and not in every household, but in the poorest and most exposed. The danger of this event, to the extent it becomes a danger to human life, will fall on specific people in specific places whose systems cannot absorb the shock. Naming who those people are, and where they live, and what stands between them and catastrophe, is the most important work left in this report. That human map is where we turn now. Now we come to the question that matters most, and the answer overturns the fear the title might plant. Who is actually exposed to this event? The instinct after walking through the 1870s is to fear for India, China and Brazil, the three lands that suffered most last time. But that instinct is wrong, and the reason it is wrong is the most encouraging fact in this entire report. Those three regions are, for the most part, no longer acutely vulnerable to a drought of this kind. The map of danger has moved. Consider how far those places have come. India today grows large grain surpluses, holds substantial reserves, and runs vast public food programs that distribute grain to hundreds of millions of people. It is an exporter of food, not a country that starves when one region's rains fail. China is a global economic power with enormous reserves and the infrastructure to move food anywhere within its borders within days. Brazil is one of the largest agricultural producers on Earth. A drought will still cost these countries money and stress their farmers, but the machinery that once let a failed monsoon kill millions has, in these places, been dismantled and replaced. This is the lesson learned, made visible. The danger has shifted instead to other regions, ones with less resilience and thinner margins. The places that worry those who track food security today lie mostly in a band across Africa and the Middle East, the Sahel, the dry belt along the southern edge of the Sahara, the Horn of Africa, where Ethiopia and Somalia and their neighbours have faced repeated drought, Yemen, worn down by years of conflict. These are the regions where a bad rainfall year still threatens to become a hunger crisis, because the systems that would absorb the shock elsewhere are weak, missing, or broken by war. What makes these regions vulnerable is rarely the weather alone, which is the 1870s lesson wearing modern clothes. It is the weather landing on a fragile human situation. A region already in conflict cannot organise a response to drought. A region that is desperately poor has no reserves and no cushion. A region dependent on outside aid is only as safe as that aid is reliable. In every case, the physical drought is the trigger, and the human fragility is what decides whether the trigger leads anywhere terrible. The exposed regions are exposed because of their circumstances, not because the sky treats them worse. This brings the report to a difficult and current question that cannot be skipped honestly, because it sits at the exact hinge the whole history identified. The regions most at risk from this El Niño depend heavily on international food aid to survive a bad year. Recently, the largest single source of that aid was sharply cut back, as major donor governments reduced their humanitarian spending. That cut lands precisely on the systems meant to catch the most vulnerable regions if this event dries their crops. The physical shock is on its way, and one of the main human defences against it has been weakened at the same moment. State the situation plainly, because it is the living proof of everything the history taught. The physics of this El Niño will do what the physics does, shifting rain away from some already fragile regions. Whether that shift becomes a humanitarian crisis will depend, exactly as it did in the 1870s, on the human systems standing between the drought and the people. Those systems are far stronger now than they were then, which is why a repeat of the old death toll is not a serious prospect. But they are not invulnerable, and choices made right now about aid and preparation will help decide how this event is remembered. That is the real weight of the comparison in the title, and it is not the weight of prophecy. The last time the atmosphere acted like this, the human systems of the day failed catastrophically, and millions died who didn't have to. This time the same atmospheric shock is arriving over a world that has mostly, though not entirely, built the defences that were missing. The event is a test of those defences aimed at their weakest points. Having found where those weak points are, we can now weigh directly how much stronger our position is than it was, and that comparison of then and now is the next step. Set the two worlds side by side, the one that failed and the one now facing the same ocean, and measure the distance between them. The 1870s drought fell on a world almost perfectly built to turn it into catastrophe. Today's world, facing a comparable shock, is built very differently, and cataloguing exactly how is what earns the confidence that this event will not repeat the old toll. The differences are real, they are large, and they are worth naming one by one. The first difference is sight, which underlies all the rest. Last time, no one saw it coming, because no one could. This time the event was named in an advisory months before its peak, its at-risk regions flagged a season ahead, its likely course tracked by satellites and buoys and models. Foresight is the foundation of every response, because you cannot prepare for a shock you do not know is coming. The single fact that we can watch this event forming, where the people of the 1870s were blind to it, changes the entire situation before any other action is taken. The second difference is the food system itself. The world of the 1870s had no meaningful global grain reserves, slow transport that could not carry relief across a subcontinent in time, and no international bodies whose job was to move food to the hungry. Today there are large reserves, fast transport that can shift grain across the world in days, a diverse global supply where a failure in one region can be covered by a surplus in another, and standing organisations built specifically to deliver food aid into famine zones. The machinery for cushioning a harvest shock entirely absent then exists now and has caught many crises before. The third difference is the state of the regions that were hit hardest, already traced but worth setting in this row of comparisons. India, China, and Brazil, the graveyards of the old event, are now food-secure powers with reserves and distribution systems that make a repeat of their old suffering almost unimaginable. The specific places that died last time have, through their own development, removed themselves from the list of the acutely vulnerable. That is perhaps the most direct evidence that the catastrophe was never fixed by the physics, because the physics has not changed and yet those places are safe. The fourth difference is knowledge and intent. The men who ran the relief in the 1870s were guided by an ideology that treated feeding the starving as a dangerous interference with the market, and that ideology shaped a response designed to be as meagre as possible. The mainstream understanding today, embodied in the existence of humanitarian aid systems at all, is that societies should act to prevent famine, not stand back and let it correct itself. That shift in the governing idea from principled non-interference to a duty to respond is as important as any piece of technology, because it points the whole apparatus towards saving people rather than away from them. Taken together, these differences do not make the world immune, and the honesty of this report depends on saying so clearly rather than ending on false comfort. The defences are strong but not perfect. Some regions remain exposed, aid can be cut at the worst moment, and a warmer baseline adds heat that the old event did not carry. The distance between now and then is not the distance between danger and total safety. It is the distance between a world with almost no defences and a world with strong but incomplete ones, which is an enormous gain but not an absolute one. Still, the direction of the comparison is unmistakable, and it should be allowed to land. Nearly every factor that made the 1870s lethal has been changed for the better. We can see the event coming, we can move food to meet it, the once vulnerable giants have grown resilient, and the guiding intent is to prevent famine rather than to permit it. A death toll in the tens of millions from this event is not a realistic prospect, and it would be wrong to let the title imply otherwise. The promise of the title is about the last time, and it is true about the last time. It is not a forecast for this one. That said, the reasons for continued care are just as real as the reasons for confidence, and they do not come from the human side of the ledger. They come from the ocean, which behaves now exactly as it always has, indifferent to every improvement we have made. To understand why vigilance is still warranted even in a far safer world, we have to look at what has not changed at all, and that unchanged core is the subject of the next chapter. For all that has improved, one thing has not changed at all, and it is the thing at the centre of the whole story. The ocean does not know that any of our progress has happened. The Pacific warms and cools today by the same physics that governed it in the 1870s, and for all the ages before. The trade winds, the sloshing warm water, the shifting rain belt, the reach across continents, none of it has been altered in the slightest by satellites or grain reserves or humanitarian agencies. The engine of the disaster is exactly as powerful as it ever was. This is why vigilance remains the right posture even in a far safer world. Our defences have grown strong, but they are defences against the consequences of the shock, not against the shock itself. We cannot stop an El Niño from forming, cannot weaken it, cannot steer its rain back where the crops need it. All our progress lives on the human side of the equation, in how we respond to what the ocean does. The ocean side is untouched and untouchable. The warm water building in the Pacific right now is the same kind of force that helped kill tens of millions, undiminished by anything we have learned. There is a further reason the old warning still stands, and it is that our very strengths can breed the weakness that undoes them. Strong systems tempt complacency. When defences have worked for a long time, it becomes easy to assume they will always work, to trust the reserves and the aid and the forecast so completely that preparation slackens. The 1870s were made lethal not only by a lack of tools, but by a failure of will and attention, and failures of will and attention are just as possible for a well-equipped society as for a poor one. A warning ignored by the capable can cost as much as a warning that never came. The recent cut to humanitarian aid is exactly this kind of vulnerability, appearing in the middle of our strong modern defences rather than despite them. It is not a failure of capacity. The world can easily afford to feed the regions this event threatens. It is a choice to devote less to that catch net at the very moment a shock is arriving that the net was built for. That is a human decision of precisely the sort the 1870s turned on. made not from inability but from priorities. The lesson that the disaster was driven by choices is not a fact safely locked in the past. It is a live description of a decision being made right now. There is also the new element that the old world did not face, which keeps the future from being a simple rerun of a solved problem. The planet is warmer now, and that added heat sharpens droughts and stacks dangerous heat on top of the El Niño's own. In this one respect, the modern world is more exposed than the world of the 1870s, not less, because the shock lands on a hotter stage. Our human defences are stronger, but the physical challenge they face has, in this way, grown. The two trends run against each other, and the outcome depends on which one wins in any given place. So the honest summary of then and now holds two truths at once, and refusing either one would be a distortion. We are far safer than the people of the 1870s, protected by sight and reserves and resolve they never had. And we are not safe in any final sense because the ocean is unchanged, complacency is possible, aid can be withdrawn, and the world is hotter. Both of these are true, and a calm reading of the event keeps them both in view, rather than collapsing into either false comfort or false doom. Safer is not the same as safe. That balance is exactly why an event like this deserves steady attention, rather than either panic or dismissal. It is a real shock, arriving over a world that is mostly but not entirely ready for it, at a moment when at least one important defense is being weakened by choice. The right response to that is not fear, and not indifference, but watchfulness. And watchfulness means knowing what to watch for. As this event moves toward its peak in the coming winter, there are specific concrete signs that will show how it is developing, and knowing those signposts is the last practical piece before we close. They are next. As this event moves through the coming months, there are specific things to watch, concrete signposts that will show how it is developing and how seriously to take it. Knowing them turns a passive worry into informed attention, which is the whole aim of a report like this. None of these signs require special equipment or expertise to follow. They are published openly and updated on a regular schedule, and understanding what each one means lets anyone track this event as it unfolds. The first signpost is the ocean temperature itself, the master reading behind everything else. The climate agencies update the Central Pacific temperature regularly, and the number to watch is whether it keeps climbing toward and past the threshold. For a very strong event, that mark of about 3.5 degrees Fahrenheit above average. If the warmth reaches and holds above that line through the autumn, the event is confirming its place among the rare strong ones. If it levels off below it, the event is settling in a step lower. That single number, tracked over the coming months, is the clearest measure of how big this becomes. The second signpost is the timing of the peak. El Niño almost always reaches its full strength in the northern winter, and this one is forecast to peak somewhere between December and February. Watching how strong it is as it approaches that window tells you how forceful its effects will be, because the peak of the ocean warmth is when its grip on the world's weather is tightest. The winter is the crux of this event. How high the Pacific climbs by then is the question the whole autumn is answering. The third signpost is the set of regional outlooks, which is where the ocean reading becomes a human concern. The forecasting centers issue seasonal outlooks for rainfall and temperature across the vulnerable regions, updated as the picture sharpens. Watch the outlooks for the places this report has flagged: the Sahel, the Horn of Africa, Southern Asia, Southern Africa, and see whether the drought risk in them firms up or eases as the season nears. These outlooks are the early warning for the regions that matter most, and any hardening of the drought signal over a fragile region is the sign that preparation there needs to move faster. The fourth signpost is the human response, which the history says matters as much as the weather. Watch whether aid organisations are funded and positioned ahead of the season, whether the regions at risk are pre-stocking food and readying relief, whether the cut to humanitarian budgets is reversed or holds. This is the signpost the 1870s teach us to watch most closely, because it is the human half of the equation that turned drought into mass death last time. A well-funded, well-prepared response before the peak is the single strongest sign that this event will pass without catastrophe. There are quieter signs to note as well, ones that confirm the pattern is behaving as expected. A quiet Atlantic hurricane season through the autumn is a sign the El Niño is exerting its normal grip, its shear suppressing the storms as predicted. Heavy rain arriving on the normally dry Pacific coast of South America is another confirmation that the warm water is doing its familiar work. These are not dangers to the wider world so much as confirmations that the event is unfolding along its known path, which itself is reassuring, because a predictable event is one our defences are built to meet. Taken together, these signposts turn the months ahead from an anxious blur into something readable. The ocean temperature shows the size, the winter shows the peak, the regional outlooks show where the risk is landing, and the human response shows whether that risk will be met. Anyone following those 4 threads will understand this event as well as it can be understood while it is still developing. That is a very different position from the one the people of the 1870s were in, watching an unnamed calamity arrive with no way to read it, and no idea what came next. Which is, in the end, the deepest change of all between then and now, and it is the note this report will close on. We can read this event. We can see it forming, name it, track it, forecast its reach, and prepare for it. The people of the last great drought could do none of that. What that difference means, and what a warning is truly for, is the final thing left to say, and it is where this report comes to rest. Return, at the last, to the warm water in the Pacific, where this whole story began. It is still building as this report closes, climbing toward a winter peak, most likely toward one of the strongest events in the modern record. That much is known and confirmed. What remains uncertain is the exact height it will reach, and precisely which of the vulnerable regions will see their rains fail, and how fully the world will prepare for what is coming. Those answers will arrive over the coming months in the readings and the outlooks and the choices yet to be made. What is known is enough to hold clearly in mind. The ocean is warm and warming, comparable in raw terms to the neighbourhood it reached in the deadliest drought of modern history. The same physics that spread that old disaster is at work now, and it will shift the world's rain, dry some fragile regions, flood others, and lift the planet's temperature for a while. That is not a fear. It is a forecast grounded in measurement, and it is the reason this event is worth the steady attention it is getting. What is uncertain deserves to be named just as plainly, because false certainty in either direction would betray the calm this report has tried to keep. We do not know exactly how strong the peak will be, though the odds favour the top category. We do not know which regions will be hit hardest, though we know which are most exposed, and we do not know whether the human systems that failed so badly last time will hold this time, because that depends on decisions, including the funding of aid, that are being made right now and are not yet settled. The physical event is coming into focus, its human meaning is still being written. The one thing to watch above all others is that human response, because the whole history points to it. The 1870s proved that the atmosphere sets the test but does not by itself decide the outcome. The drought was terrible, and the deaths of tens of millions came from the drought passing through human systems that failed to protect people. The single most important thing to watch as this event unfolds is whether the world, and especially the regions at risk and the donors who support them, prepares in time. That, far more than the exact temperature of the Pacific, will decide how this event is remembered. And here is the reason a report like this exists at all, the reason for walking so carefully through both a warm ocean and a century-old catastrophe. A warning is not a prophecy, it is the opposite of one. A prophecy tells you what will happen and leaves you helpless before it. A warning tells you what could happen so that you can act to keep it from happening. The tens of millions who died in the 1870s had no warning, and the world that failed them could not have heeded one if it came. We have the warning they lacked. The whole point of having it is that our story does not have to end the way theirs did. That is why the title of this report, true as it is about the past, is not a forecast for the present. The last time the atmosphere acted like this, millions did not survive, and that happened because a natural shock met a world with almost no defences and little will to mount them. This time the same shock is arriving over a world that can see it coming, that can move food to meet it, that has mostly built the systems the old world lacked. Whether it uses them well is the open question, and it is a question about choices, which means it is a question we can still answer correctly. So this report ends not on the number in the title, but on the difference between then and now. The ocean is unchanged and indifferent, and it will do what it does. Everything else has changed, and it has changed in our favour if we hold to it. Watch the water climb toward its winter peak, watch the outlooks for the regions that matter, and watch whether the world prepares. Stay informed and stay steady, and we'll follow this one together as it develops. The next report will be here when there is more to know.